Hey guys, in today's episode of How to Wire It, we're going to take a look at these little guys. These are Piezo discs. And they're really, really cool for quite a few reasons, but first of all is that they're really easy to find. So these come in a ton of cheap little products. They're usually, you'll find them used as cheap little speakers. And I'll show you guys how to use them as those. And they usually come, if they're in a speaker, they usually end up looking something like this. This is a 24 volt buzzer speaker out of a security system. And, you know, when your computer makes a little beep when you start it up, that's one of these little guys. Those cheap little piano toys for kids, those are usually these little guys. They're not actually speakers. So these are really easy to find, and they have two uses. So you can use them as both an input and an output. As an output, like I said, they're used often as little speakers or buzzers. And as an input, they can be used as little vibration sensors or knock sensors, basically ways to detect whether there's movement. Physical movement, not like movement, a motion sensor. But so these little things, they can be used for, I'm going to show you guys that they can be used to detect knocks or anything like that. You could put something on one of them, and when you take it off, it'll detect that. So you could make like a little, Mission Impossible style, sensor for moving something to detect, like a museum would detect if you took something off of it, pressure plate. You can also use them as sensors to detect if somebody's knocking on your door. Basically, they have a ton of uses, and they're really cheap and really easy to wire up. So to get started, you just need to plug your sensor into your board, into your breadboard somewhere. So I've just plugged mine in like that. You'll want to take a red hookup wire or a positive hookup wire and connect it to the positive connection on your board somewhere. You'll want to take your resistor now and plug that from the other side of the sensor, not connected to power, and plug that from the other side of the sensor into ground. And lastly, you want to take a piece of hookup wire here and connect it from that same point that we connected the resistor here and connect it to your Arduino on an analog input pin. So now this is all wired up and ready to see how the software works. So let's take a look at that now. So as you can see, I have just the standard Arduino graph program loaded here. And all that I've done to this program so far is I've just changed the analog read pin from A0 to A9, which corresponds to my analog input on my Arduino here. You want to make sure that this is set to whatever input pin you're using on your setup, but for me it's A9. And I'm going to upload my program. And now we should be able to, if you have a newer version of Arduino, 1.67 or higher, I believe, you should be able to go to the serial plotter. And right now we have this little blue line going across, but if I touch the sensor here, look at that. Instantly we detected my presence, my touching it. And this can go even further. I bet if I tap on the table here, you can see it's detecting that as well. So, and I wonder if I put this on top of it. Okay, it's detected it, and if I take it away, look at that. So you can see that this has a ton of uses. You can use it to detect knocks or whatever, and it's really, really cool. So, that's how that works. Now, I did say that I had a couple of other resistors here. So I have a 10K connected right now, but if I swap this out, this 10K out for 100K, it should be even more sensitive. So now even smaller taps on the table set it off, and you can see the values that it's jumping to are higher than before. And I know it's a little bit hard to see because this is automatically scaling everything, but the values are definitely significantly different. So now let's take a look and see what happens if we plug in a 1K resistor. So the 100K should have increased the sensitivity, and now the 1K you can see the graph is still spiking, but if you look at the numbers on the right, they're much smaller than they were before. And in fact, when I put this on there, it's barely detecting my removing it at all. So if you need to scale the sensitivity of this for a specific project, the way that you do it is by changing the values of your resistors. And, you know, if you need something to be kind of very fine-tunable, you can even swap this resistor here out for a potentiometer. That way you can really twist it and tune it and make it work for whatever your project is. So that's how to use one of these as an input. Now let's go back to wiring and see how to use one of these as an output. So to wire this as an output, it's even a little bit more simple than wiring the input. All you need is you need to have a spare pin on your Arduino. And this, I believe, somebody in the comments correct me if I'm wrong, but I believe this pin does not need to be an analog output pin. So you just need a regular pin anywhere on your Arduino and plug it into the positive side of your sensor. Well, not a sensor anymore, now it's more like a speaker. And the other side of the speaker, you'll want to connect to ground. So that's it for that wiring right there. That's all you need to do. So now to code it, to write software to make it make sound, we have, if you go into the Arduino program and you go to example, digital, and you go to tone melody, or any of these tone examples here, you'll get a program like this. This is specifically the tone melody program. And in this, it has a header file with a bunch of different pitches, bunch of different notes. And so these are all definitions of different notes that correspond to their frequencies. So you don't have to remember the actual frequency in hertz, but all you have to remember is that if you want, you know, C4, you go and you select C4. I don't really know anything about audio or tones or anything, so that's pretty foreign looking to me. I'll just accept it as it is. And in our program here, we create a couple of arrays, and these correspond to our to our notes and our durations for each note. And so our melody here is this arrangement of notes, and this is all the tones that we have in here. And our duration is how long we want these notes to play for. So you can see 4 is a quarter note, 1/8 is an 1/8 note, and so on. So then inside of setup, we have our little melody that we want to play. And what we do is we run through a for loop that goes and uses each of these note and duration pairs and puts them into this tone function. And tone basically takes a pin, a note, and a note duration. So we can see this note duration is actually, it's not directly this duration here, but it's taking 1,000, so 1 second. So if our quarter note is a quarter of a second, we take that and we divide it, 1,000 divided by 4, and we get 250, which is a quarter of a second. So we plug that into here, and it plays that tone. And we have a small pause between notes so that we can basically differentiate between the individual notes themselves. Very small delay. In fact, you can see in the comments where that delay is coming from. And then at the end of all this, we call no tone. And no tone basically just turns off the tone on that pin. And I will note that you can only use one tone pin at a time. So you can't, I don't believe you can call tone on multiple pins at once. You can only call it on a given pin at a time, which is why you do have to call no tone. So now let's plug this in and see how it works. Well, I'm not sure if the microphone picked that up. It's pretty quiet because normally, in order to get loud sounds out of this, you do need this kind of shroud here that amplifies it. But maybe if I bring the mic in a little bit closer, you can hear it a little bit better. So, there you have it. That is how you use a piezo disc. And you can keep them in these little speaker packages. You don't have to take them out, but to use them as inputs, as sensors, I find it easiest if you just sort of pry up this little back part here. You do have to be careful because they are sensitive and you can break them pretty easily. But if you pry up the back, you can usually take out the whole element there and use it for whatever you want. So that's all there is for today's video. If you like these videos, go check out one of the other videos on screen now. And if you like this kind of stuff in general, subscribe to the channel. Alright, well, thanks for watching. I'll see you guys later.